Hello everyone, welcome to Mana CS Classroom. Today we are starting one of the most important subjects in computer science, data structures. Whether you want to become a software engineer, data scientist, AI engineer, full stack developer, or crack coding interviews, data structures is the foundation. Before learning any programming language deeply, we must understand how data is organized inside a computer. That is exactly what this subject teaches us. Suppose all of your books are arranged properly. First year books అన్నీ ఒక దగ్గర, second year books అన్నీ ఒక దగ్గర, third year books అన్నీ ఒక దగ్గర. Then finding a notebook takes just seconds. Now imagine all books are thrown randomly into a cupboard. Finding one notebook becomes a mission impossible task. Computers face exactly the same problem. They store huge amounts of data. Without organization, finding information becomes difficult. Every day we use applications like WhatsApp, Instagram, YouTube, Amazon, banking applications. All these applications handle enormous amounts of data. Imagine YouTube searching through billions of videos whenever you type a keyword. Imagine a bank searching through millions of customer accounts. How do computers manage such huge data efficiently? The answer is data structures. Before learning data structures, let us first understand data. Data simply means raw facts and figures. For example, student name, roll number, age, marks. These are individual facts. These facts together form data. Suppose I simply say marks is equal to 85. This is just data. Now suppose I say the student scored 85 marks and secured distinction. This becomes information. So remember, data is raw, and when you process the data, you will get the information. So data is raw, information is meaningful processed data. A data structure is a method of organizing and storing data so that it can be accessed and processed efficiently. Notice one important word here, efficiently. Computers not only store data, they constantly search, insert, delete, update, process the data. Data structures help perform all these operations quickly. Without proper organization, processing large data becomes slow. As the software grows, number of users increase, amount of data increases, complexity increases. Therefore, efficient storage and retrieval becomes essential. That is why data structures are required. Good data structures make all these operations faster. Almost every data structure supports some common operations. Searching means finding an element. Insertion means adding data. Deletion means removing data. Traversal means visiting all elements. Sorting means arranging data in a particular order. Merging means combining multiple collections of data. These operations form the backbone of any data structure. All data structures perform these common operations. Data structures are broadly classified into two categories: primitive data structures, non-primitive data structures. Primitive data structures are basic data types directly supported by programming languages. Examples: integer, float, character, double. So these are called as primitive data structures. These act as building blocks for the construction of other data structures. Next one, non-primitive data structures. Non-primitive data structures are more advanced structures used to organize larger collections of data. They are again classified into linear data structures and non-linear data structures. Linear and non-linear data structures. So let us briefly understand each one. In linear data structures, elements are arranged sequentially. Elements are arranged sequentially. One element follows another. Examples: array, linked list, stacks, and queues. Arrays store elements in contiguous memory locations. Okay, so room number 101, 102, 103, 104, 105. Like that, in consecutive memory locations, array elements will be accommodated. For example, marks of a particular student. Next one, linked list. Elements are connected using links. Okay, they may not stored in contiguous memory locations. They may be scattered throughout the memory, but first element remembers the link of the second element. Second element remembers the link of the third element. Third element remembers the link of the fourth element. Like that, elements are linked to each other in linked list. Okay, dynamic in nature. And next one is stack. So this is like you can imagine, suppose మన కిచెన్లో సపోజ్ అమ్మ చపాతీలు చేసింది అనుకోండి, అండ్ షీ స్టోర్స్ ఆల్ ద చపాతీస్ one on the top of another one like this. So you can call this as a stack of chapatis. Suppose క్యాంటీన్లో ప్లేట్స్ అనుకోండి, ప్లేట్స్ ఎలా అరేంజ్ చేస్తారు. సో one on the top of another one, right? And whichever is inserted in the last place comes out first one. సో ఈ ప్లేట్స్ ఇలా ఉన్నాయి. ఫస్ట్ మిమ్మల్ని తీసుకోమంటే ఏ ప్లేట్ తీసుకుంటారు? టాప్లో ఉన్న ప్లేట్ని తీసుకుంటాం కదా మనం. ఓకే, టాప్ నుంచి తీసుకుంటాం కదా యూజువల్లీ. సో లాస్ట్ ఇన్ ఫస్ట్ అవుట్ ప్రిన్సిపల్. సో దట్ ఈస్ అ స్టాక్. అండ్ నెక్స్ట్ వన్ ఈజ్ క్యూ. క్యూ ఈజ్ లైక్ వీఆర్ స్టాండింగ్ ఎట్ అ టికెట్ కౌంటర్. సపోజ్ సినిమా టికెట్ తీసుకోవడానికి వెళ్ళామనుకోండి. ఇప్పుడంటే అందరం ఆన్లైన్లో బుక్ చేసుకుంటున్నాం. నార్మల్గా టికెట్ కౌంటర్లో నిలబడ్డాం అనుకోండి. person, this is a ticket counter. So persons one behind the another person, ఇలా ఒకరి వెనకాల ఒకరు నుంచుంటారు కదా. సో ఫస్ట్ ఉన్న వాళ్ళకి టికెట్ ఇచ్చేస్తే వెళ్ళిపోతారు. నెక్స్ట్ సెకండ్, నెక్స్ట్ థర్డ్, నెక్స్ట్ ఫోర్త్. సో ఎవరైనా ఈ క్యూని జాయిన్ అవ్వాలంటే బ్యాక్ సైడ్ నుంచి జాయిన్ అవుతారు. ఎవరైనా క్యూని లీవ్ అవ్వాలంటే ఫ్రంట్ సైడ్ నుంచి లీవ్ అవుతారు. సో ఫస్ట్ ఇన్ ఫస్ట్ అవుట్ ప్రిన్సిపల్. క్యూ ఫాలోస్ ఫస్ట్ ఇన్ ఫస్ట్ అవుట్ ప్రిన్సిపల్. సో ఎగ్జాంపుల్ టికెట్ రిజర్వేషన్ సిస్టమ్ అండ్ ఇలాగే టికెట్ కౌంటర్స్. ఇది ఇన్ డీటెయిల్ అబౌట్ ఎవ్రీ డేటా స్ట్రక్చర్ వీ విల్ స్టడీ లేటర్. అండ్ కమింగ్ టు నాన్ లీనియర్ డేటా స్ట్రక్చర్స్, there are two non-linear data structures and elements are not arranged sequentially. They can connect to multiple elements. Examples, trees and graphs. Trees used to represent hierarchical relationships like superior and subordinates or parent-child relationships, hierarchical relationships. For example, principal, next HODs, and HODs in the faculty, like that, hierarchical relationships. Okay, example, folder structures, organization hierarchy, all these are examples of trees. And then graphs used to represent networks. Example, Google Maps or social network. Mana friends unnaru anukondi, A is friend of B and also C. B is friend of D, also C. And D is friend of C and E. It is simply resembling a network. Okay, so this is called as a graph, and the main examples for graphs are Google Maps, social networks, computer networks. So these structures are heavily used in modern applications. So data structures are not just theoretical concepts, they are used everywhere. When you click the browser back button, a stack is working. When you book train ticket, a queue is working. Windows folders use trees. So home folder లో MVSR folder, MVSR folder లో CSEA section, CSEA section like this. Okay. So Windows folders use trees, Google Maps use graphs. So without data structures, modern software applications would not exist. So today we learned what is data, what is information, what is data structure, why data structures are needed, classification of data structures and their real world applications. In the next video, we will start with the detailed explanations of each and every data structure. Until then, happy learning and don't forget to subscribe to Mana CS Classroom. Thank you.